Hi guys, welcome back. I am Ajit from SCCA and I belong to Department of Electronics and Communication. So the subject for today is computer organization and architecture. The topic is related to performance of a computer. The basic idea is that good performance results from achieving a good throughput while keeping the response time low. A system that can efficiently process a significant amount of work in short time is considered to have good performance. The basic performance equation in the context of computer systems can be expressed as performance equals to throughput divided by response time. This equation relates to two key metrics. The first one is throughput. This represents the amount of work or data that a system can process in a given time. It is often measured in terms of transactions per second, instructions per second, or data transfer rate. The second one is response time or latency. This is the time it takes for a system to respond to a request or perform a task. It includes both processing time and waiting time. The execution time or runtime of a program in a computer can be expressed using the following equation. Execution time equals to instruction count multiplied with CPI multiplied with clock cycle. Here's the breakdown of the terms in the equation. The first one is execution time. This is the time taken to a program to execute from start to finish. It is usually measured in seconds. The second one is instruction count. This represents the total number of instructions that a program executes. Each instruction contributes to the overall workload. Third one is CPI, which is cycles per instructions. CPI is the average number of clock cycles required to execute one instruction. It reflects the efficiency of the instruction execution in terms of clock cycles. Clock cycle time. This is the duration of one clock cycle, which is determined by the clock speed of the processor. It is usually measured in seconds per cycle. To measure the performance of a computer, you can use a combinational benchmarks, monitoring tools, and real-world testing. Here's an overview of how you can approach performance measurements. So the overviews are benchmarking, monitoring tools, application-specific testing, storage performance, network performance, real-world usage, temperature, and power consumption. The first objective, which is used to measure the performance of a computer, is called benchmarking. So, the usage of benchmarking software is to assess specific components like CPU, GPU, and storage. Examples include Geekbench, Cinebench, 3D Mark, and Crystal Disk Mark. Consider comprehensive benchmarking tools like PCMark that provide an overall assessment of the system's performance. Here, as you can see, the steps for benchmarking: define the focus, select benchmarking partners, gather data and information, analyze and compare, set performance targets, develop an action plan, implement the monitor, learn and iterate. So the benchmarking is generally divided into performance, process, survey, measurement, compare, target, and indicator. The second one, which is used to monitor the performance of a computer, is monitoring tools. This one utilizes built-in tools like Task Manager for Windows or Activity Manager for Mac to monitor real-time CPU usage, memory usage, disk activity, and network activity. Use more advanced monitoring tools like HWM Monitor or Resource Monitor for Windows for detailed insights into resource utilization. So the left image shows the Task Manager for Windows, and the middle one is for Activity Monitor in Mac. The HWM Monitor is an advanced monitoring tool, and the Resource Monitor for Windows is the foremost right one. The third one is application-specific testing. This evaluates the performance of specific applications you frequently use, such as graphic designing applications or high-end games. This could involve measuring load times, responsiveness, and overall user experience. The fourth one is storage performance. This assesses the read and write speed of your storage devices using tools like Crystal Disk Mark or ATTO Disk Benchmark, which are specific softwares which are used to assess the read and write speeds of your storage devices. The fifth one is network performance. This tests the bandwidth and network bandwidth and latency using tools like Speedtest or IPERF. The software called Speedtest, which is owned by Ookla, is a common software which is used to determine the network performance. IPERF is a more advanced testing application for network bandwidth and latency. Sixth one is real-world usage. This performs real-world tasks like evaluate how quickly the system responds. This could involve running software, opening files, or handling complex computations. The seventh one is temperature and power consumption, which is the last one. This monitors the system's temperature using tools like HW-Info or CoreTemp. These are two softwares which are used to monitor the system's temperature and assess power consumption to understand the efficiency of the system. So here we can see the HWI info's icon, and the below one is the normal Windows integrated tool which is used to study the system's temperature. While keeping in mind that performance evaluation should be context specific, the requirements for a gaming computer, for example, may differ from those of a workstation used for content creation or a server handling large-scale data processing. Consider your specific use case and tasks for your computer that needs to perform while assessing its performance. Thank you.